Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I am going to go over solution dilution. In other words, I'm going to be going over M1V1 equals M2V2. So basically in this video I'm going to be going over how do you do dilution problems. And so these are going to be problems where you have a certain already set up molarity of a solution and you want to find a volume of a new solution, or you want to know what volume do you need if you want a certain like molarity involved. So the first thing I want to go over is why this equation, dilution equation, works and where does it come from. So if we remember that the molarity is equal to moles of solute over liters of solution, then we can solve for the number of moles. Like if I have a given volume of a solution, I can figure out how many moles are in that solution if I know the volume and I know the molarity, because then I can just multiply both sides. If I multiply both sides by the volume, the liters, right? So that'll cancel out and then multiply there. So this will be volume, right? So instead of liters, let me put volume. So the volume is in liters. So the equation would be molarity over volume, moles over volume in liters of the solution. So if I multiply both sides by V, or volume, then what I get is the volume multiplied by the molarity is equal to the number of moles. So let's say I start out with a certain amount of solution at a certain molarity. I can take the volume of that solution, multiply by the molarity, and I get the moles. Now, where this comes in with dilution is I can take a certain, let's say I have a certain stock solution, right? And I put a certain number of milliliters in here. So let's say I put a certain number of milliliters of my stock solution, and so I know the volume. Let's say this is 20 milliliters, and I know the molarity. So I can calculate the number of moles that are in this volume here that I took. So I multiply the volume by the molarity, and that's going to give me a certain number of moles. So I can figure out how many moles of my solution is in there that I put into the flask. So once I know the moles, when I dilute it, all I'm going to do is add water. So if I'm adding water to this flask, am I changing the number of moles that I put in there? Am I adding more of my solute if I'm just adding water? No, the answer is no, because all I'm doing is adding water. So the number of moles of my solute, the molarity, the number of moles that I have that I added to the flask before I started adding water is the same after I added water, right? So the only thing that's going to change is the concentration, the molarity. The concentration is going to change because I'm adding more water and I'm increasing the volume of the solution without changing the number of moles that I put in there. So if the number of moles doesn't change, then I'll start off with whatever I start off with. Let's call this V1, and then I started off with a molarity. Let's call that molarity M1. So that's what I started off here, right? So this is situation one, and then I add water to it, and then I get this situation where now the water is up to here, and now let's say it's 40 mils, right? So all I did was add more water, and so this would be situation two. And so now I'm going to have the same number of moles, but now I'm going to have a different volume. Obviously, I have a different volume, so I'm going to have a V2. And then I'm going to have a different molarity as well, and we'll call that M2. So before I diluted, I had a certain number of moles in there. And then after I dilute it, I have the same number of moles. If I know that the volume times the molarity gives me the moles, and I know that before in situation 1 and after in situation 2, the number of moles of my solute did not change, then the V1M1 has to equal the V2M2 because this is also equal to moles, right? So if this is equal to moles, and this is equal to the moles, and the moles stay the same, then that means that M1V1 has to equal M2V2. And so that's where that equation comes from. And that only works for dilution, because it's in dilution that I am just putting water and I'm not changing the amount of moles in the solute that I have originally. So I just wanted to explain that to like make it clear where this equation comes from and why it works. And so you'll notice that these are going to be inversely proportional to each other. It means like if you increase the volume, you're going to decrease the molarity. Or if you increase the molarity, the volume is going to decrease. So they have that relationship as well. So I hope that's clear. So let's go ahead and solve these two problems. So in problem number 1, it says, to what volume should you dilute this number of liters of this molarity? So we're gonna start with this liters and this molarity. So that's gonna be our V1M1. So when you do these problems, you label what your things are. So we're going to say our V1 is equal to the 0.200 liters, and our M1, our beginning molarity, is 15.0 molar. Okay, and then they want us to dilute that and get a different thing. So we're going to have our goal is 3 molar solution. We want to get a 3 molar solution, so that's going to be our M2. And so they're saying, what volume should you dilute to, right? So that's the V2 that we're looking for. So V2 is what we are looking for. So now all we need to do is just plug everything into the equation. So we have M1V1 is equal to M2V2. We're looking for V2, so why don't we just solve for V2 so we can multiply both sides by M2. So the M2's cancel out. So now we have V2 is equal to M1V1 over M2. So now all we need to do is plug in the values here into here. So that would be equal to, so M1 is going to be 15.00 molar. V1 is going to be, where's V1? 0.200, so we have 0.200 liters. And then we're going to divide that by M2, which is 3.00 molar. So the molars are going to cancel out. We're left with liters. So now all we need to do is calculate the answer. So here we get 15 times 0.2 divided by 3 equals, and we get 1. So the answer is going to be 1 liter. Or to be careful, we need to make sure we have the right sig figs. So remember, if you're multiplying and dividing, the least number of sig figs is in your answer. So we have 4 here, 3 here, and 3 here. So when we write this as 1, we can't just write it as 1. We need to write it as 1.00 liters. And so that's the volume that we should dilute our solution to. Okay, and we could actually predict this, because if we recognize that molarity and volume are inversely proportional, so if you increase one by a factor, then the other decreases by the same factor. So if you look at the molarity here, molarity is going to go down from 15 to 3. That's a factor of 5, right? So if your molarity is decreasing by a factor of 5, then your volume should increase by a factor of 5. So if you multiply 0.200 by 5, you get 1.00. Okay, so you can see that as well without doing calculations. But most problems are not going to be that simple. But you could always check your work to make sure your answer makes sense based on that. All right, let's look at here. So to what volume in milliliters, now we want milliliters, should you dilute 100 milliliters of the 5.00 molar calcium chloride solution to obtain a 0.75 molar calcium chloride solution? So what's our volume? Our V1. So to what volume? That's going to be V2. Our starting volume is 100 milliliters. We got to convert that to liters if we're using molarity, because liters are in molarity, so that's going to be 0.100 liters. Our beginning molarity is 5.00, so 5.00 molar. And our ending molarity, our final molarity that they want, is going to be M2, and so that's 0.750 molar. And then finally the V2 is what they need to find. So that's what we need to find. So we're going to set up our equation. So again, we have M1V1 equals M2V2. We're looking for V2 again, so we're going to solve for V2. So M2, divide both sides by M2, and that goes away. So then V2 is equal to M1V1 over M2. So now we just plug in our values. So M1 is 5.00 molar. V1 is going to be 0.100 liters. And we're going to divide by M2, which is 0.750 molar. And so once again, the molarities cancel out. And then you got liters. And so you do the calculation. And so here we're going to do 5 times 0.1 divided by 0.75 equals, and here you get 0.666666, so we get 0.6666 and so on. So that's going to be liters, but we want milliliters, so we need to multiply that by 1,000 to get our milliliters. So we would convert that using our conversion factor, but really quickly that would be 666.6 so on milliliters, and then we check our sig figs. We have 3, 3, and 3, so we're only allowed 3 sig figs, so we gotta cut it off there. So our final answer is 667 milliliters. So that's the volume that we need to dilute to get our wanted molarity, so 0.750. And again, you can check to see, so we're going from 5 to 0.75, right? So we're decreasing by a bit, you know, and then you would expect the volume to increase. So we're going from 100 to 667. So it definitely increased by a bit. So that's the direction you would expect. So we probably did this right. I hope I did this right. I hope you enjoyed this video. I hope this was helpful. And if you like this video, like it, share it, subscribe to the channel. make a comment in the comment section. Let me know what you think, and ring the bell, notification bell, so you get notifications for other videos. Thanks for joining me, and I'll see you next time.